Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi everyone, welcome back to Geeks for Geeks practice. So today we'll be discussing another problem of the day that was for 9th of November, minimum sum partition. So quickly give me a +1 if my voice is clearly audible to everyone. Of the day that was for 9th. Okay, I think it works fine. Minimum sum partition. So all of you can just quickly give me a +1. Hi Hussein, hi Naikaj, hi everyone, hi Imran. All of you can quickly hit the like button and give me a +1 in the chat so that we can start. Okay, so a lot of +1s. Hi Rishit, hi everyone. Great. So let me do one thing. Let me add my screen as well. Okay, so I hope that my screen is visible as well. You can write yes in the chat for this, and then we will start with the problem as well. Hi Ashton. Thanks a lot, Shubham. Okay, so how many of you have solved this particular problem? The problem of the day for 9th of November, that is for yesterday, was minimum sum partition. Okay, now this particular problem, okay, the problem name is nothing but minimum. Okay, the problem name is minimum sum partition. Okay, the problem name is minimum sum partition. It has been asked in Amazon and it has also been asked in Samsung. Okay, and talking about this problem, so if you will see this particular problem right here, so let me remove the code first. Okay, so if you will see this particular problem, it says that this problem is hard. Okay, it says that this problem is hard, but this is not a hard problem. You will write M in the chat. It is a medium level problem. Okay, please write M in the chat, guys. It is a medium level problem. So as an acknowledgement, please write M in the chat. Like this is a medium level problem, not a hard level problem. So just quickly write M in the chat. Okay, many people are writing M. Correct? All right, great. So what you have to do in this particular problem, that is the thing, right? So suppose we take this particular copy, this particular test case first of all. Okay, आज का 30 days वाला live बाद में, yeah, it will be done after. I think Gaurav had some network issues. All of you can hit the like button, okay, guys, because I can see a lot of people are watching. So please make sure to hit the like button if you haven't, because the number of likes are less compared to the number of people live. So it says that you will be given an integer array. Okay, you'll be given an array. Okay, that will consist of non-negative integers, and the task is to divide it into two sets. Okay, basically two sets. So it says that you will be given what? You'll be given an array. Okay, basically what you will be given is you will be given a particular array. Okay, let's say it is ARR. You'll be given this array. Now you need to make two sets. Okay, let's say you need to make set one. Okay, let's say set two, or you can say subset also, right? Subset, you can say subset. You can say subset one you'll make, and you'll make another subset two. Okay, so some elements you will put in the first, some elements from this array you will put into the first subset, into the first set, you can say, and some elements you will put into the second one. Okay, is that clear? Now once you have done this particular thing, then you can say that there will be a sum one. Suppose that the first subset, the sum of all the elements of the first subset is nothing but sum one, and the sum of the all the elements of the second subset is nothing but sum 2. Okay, then the problem says that, then this particular problem says that, suppose that the sum is s1 s2. Okay, you can say it as sum 1 and sum 2 as well. The absolute difference between these two sum should be minimum. Okay, so what you need to do is you need to divide, you need to distribute the elements into the two subsets, and you need to find the minimum value of sum 1, okay, minus sum 2. Is that clear to everyone? The problem statement is clear to everyone or not? Just quickly let me know this. Okay, problem statement is clear that you will have some elements in the array, you will distribute some elements into the first subset, maybe you will distribute some elements into the second subset as well. Then the first subset will be having the sum as sum 1, suppose some second subset will be having the sum as sum 2, right? Then what you will do is you need to find the minimum value of the absolute of sum 1 minus sum 2. Correct? Okay, Hi, Vanshika. Okay, great. So this is what the problem says, right? Now, what can we do for this particular problem? So if you will observe going further, right? So let's take the sample example here, right? Let's take the sample example. Okay, so I need to copy that directly. So 1 6 11, and we have, suppose that we have 1, we have 6, okay, we have 11, and then we have 1 6 11 and 5. Okay, these are the elements that we have. So maybe one thing that I could do is I can put, let's say, the elements, like if I put it like this, suppose that I put 1 and 5 together. Okay, suppose that I put 1, the element 1 and 11 together, okay, and then I put 6 and 5 together. Okay, so what will be the, like, out of this, if I put 1 and 11 together and I put 6 and 5 in the second subset, right? So what is the sum 1 here? Sum 1 comes out to be what? Sum 1 comes out to be 12, and you can see that the sum 2 comes out to be 11. Okay, now when I do this thing, so what happens? I can simply say that the absolute value now of sum 1 minus sum 2 is nothing but what? Absolute of 12 minus 11, that comes out to be 1. Correct? Please write 1 in the chat. 1 in the chat. Correct? That is what is happening here. And also hit the like button if you haven't, because a lot of people are watching, and I don't want lesser number of likes if a lot of people are watching. All right. So this is what is happening. This is what is happening here. Right. This is one thing. But see, you cannot directly predict which elements you should distribute to which subset, right? So I will try to do what? I will try to do what? See, can I say that I will try to have all possible, right? I'll try to apply all possible combinations, right? All possible combinations, right? I'll try to do what? I'll try to apply all possible combinations. Please write all in the chat. Please write all in the chat. Like, are you understanding this fact? Like, I can make a lot of subsets, right? I can make a lot of subsets. So I'll try to make all possible combinations, and for all possible combinations, I'll try to find the minimum value of the absolute of S1 minus S2. Correct? That is what I'm going to do. Now, when I say that I'll try to have all possible combinations now, so what comes to your mind, guys? What comes to your mind when I say all possible combinations, right? When I say all possible, right, all possible combinations, right? When I say that all possible combinations, or when I say all possible scenarios, let's say, so in this case, what comes to our mind? The thing that comes to our mind is nothing but recursion, right? Recursion. Please write recursion in the chat. REC in the chat. You can write REC in the chat, or you can write +1 in the chat. Correct? All possible scenarios is what? All possible. How can we generate all possible scenarios for ourselves? We can generate all possible scenarios by using the concept of recursion. Definitely, yes. Right? You can write REC in the chat and hit the like button if you haven't. I'm still insisting. Correct? That is one thing that you can do. Like, you need to apply recursion. Okay, now, do you like understand this thing, guys? Like, let's say there are some elements. Okay, there are some elements. Okay, and there are some elements. Okay, suppose that you want to make the subset 1. Like, let's say you want to make the subset 1. Okay, suppose you make the subset 1. Okay, so do you actually need to make both the subset 1 and subset 2? No, you don't need to make the subset 1 and subset 2 both. Okay, you don't need to do so much thing manually now. Will you make the subset 2 and subset 1 both? No. That will be a very hard, like, that will be a lot of hard work now. What you will do is you will do smart work here. You will do smart work. Okay, you will do smart work. What I am saying is, when you are talking about subset now, suppose that if I'm able to make the subset 1, okay, suppose that I will try to make what? I'll try to make all the possible subset 1s. Okay, like, all, I'll try to make all the possible, I will try to make all possible subset 1. Okay, I'll make only one subset. Okay, and suppose that I am using some elements. Okay, suppose that I'm using some elements to make the subset 1. Okay, and it is having the sum as sum 1. Okay, how can I get the subset 2? How can I get the subset 2 directly? How can I get the sum of the subset 2? Like, suppose I make the subset 1 and I get it sum, right? I get it sum, right? So I can say that, how can I get the subset 2? I can simply get the subset 2 by doing what? The total sum, right? Total sum of the array, total all the elements of the array, minus the subset 1 sum, right? Minus the total sum of elements that I have taken in the subset 1. If I'll do that, so that is how I'll get the sum 2. Is that clear to everyone? Is that clear to everyone? Is this particular concept clear? You can give me a +1 for this if you're clear with this. I don't directly need to generate the subset 2. Somehow I will generate all possible subset 1 only, right? I will try to generate all possible S1. Okay, all possible sum one. I'll try to generate all possible subset one by taking some elements, not taking some elements. I'll try to do this particular thing, right? And then I can directly generate the subset two, right? How can I directly generate the subset two? Because I don't want to generate the subset two actually. I just want the second subset sum, right? So if the total sum, if the total number of if I take all the elements, then there will be a total sum to it, right? After that, if I subtract the subset sum of the subset one that I have currently made, then I'll get the sum of the subset two. Is that clear? So basically, I'm saying that if the sum of the subset one, let's say, is S1, okay, and what is then what is the sum of the subset two, guys? The sum of the subset two, that is nothing but S2, is equal to what? You can say total, right? Minus what? Total minus S1, right? Total sum minus S1, correct? This is okay. Thanks a lot, Shubham. Thanks a lot. Yeah, exclude. I will come to this now. I'll come to this. How will we generate the subset one? Na? That I will come to. Don't worry. Okay. Now another thing that we need to notice here is that we need to notice here. Okay. Hi, Amit sir. Okay. So what we need to do is we basically need to do what? If you will observe, so what is like if let's say we have to minimize the value of absolute of s2 minus s1, suppose, right? Or you can write s1 minus s2, whatever you would like. Okay, if you want to do this particular thing, so in this particular case I will write absolute of what? Absolute of, you can say, s1 s2 is what? Total sum, okay, minus s1 and minus s1 again, right? Because s2 is what? S2 is nothing but total sum minus s1, so I've written it here, minus the s1 value as well. Okay, minus the s1 value as well. So I will try to do what? I will try to minimize this particular thing. This will be what? Now the expression comes out to be total sum minus s 2 times s1. Is this particular thing clear? This particular equation is going to be used. Is it clear? Total sum minus 2 into s1. Is that clear? I will try to generate all the possible subset 1 sum. Okay, I'll try to generate all the possible s1, guys. Okay, I'll try to generate all possible s1. Okay, and once I generate all possible s1, so I'll try to find the minimum value of this. Is this part clear? That is, this particular equation is clear pretty much. Like, sum of the subset 1 is s1, right? Subset 2 sum is what? Total sum minus s1. So the equation becomes s2 minus s1. That is nothing but total sum minus s1. That is the sum of the subset 2 minus the sum of the subset 1. So the equation is nothing but total sum minus 2 into s1. Is that clear? Everyone can write a +1 in the chat. Is everyone clear with this particular part? Then only I will proceed further. And make sure to hit the like button if you are clear with this particular concept. Are people clear with this? At least for now. At least for now. That if the sum of the subset 1 is what? S1. Okay. Now the sum of the second subset will be what? Total sum of the array minus the sum of the subset s1. That will be because you have to distribute all the elements either in the first subset or in the second subset. So after distributing some elements in the first subset, if the sum is s1, then the second subset sum s2 will be nothing but total sum minus this thing. So the absolute value of s2 minus s1 is going to be what? It is going to be absolute of s2 is what? S2 is nothing but total sum, guys, minus s1. Okay, this thing minus s1 is again done. So that is going to be nothing but what, guys? Total sum minus 2 times s1. Okay, and I need to take the absolute value of this. So please write m in the chat. I need to minimize this value now. Please write +1 in the chat, or agree in the chat, or min in the chat. Whatever you want to write, you can write. Is this part clear? This equation must be clear. Then things will be more clear, right? This is what I want. Okay, this is the kind of thing that I want. So I want to minimize this value. I want to minimize this value. Okay, you can write a +1, a in the chat, m in the chat, whatever you feel like. All right, everyone is clear with it? Great. Now going forward, what should I do? So if you will observe now, I will try to see what is a subset, right? What is a subset? Let's suppose if I'm at the ith element now, so I can do what? Either I can take, I don't know why my OneNote is behaving like this. I can take the ith element, okay? Okay? Or I can not take, right? Not take, or you can say skip the ith element, right? If I take the ith element, then my sum will become what? My sum will become s1 will become what? Subset 1 sum will be what? S1 already existing plus the ith element, right? But if I don't take it, then it will remain the same. So it will remain s1. Is that clear? Is that clear? So we will try to check for all possible scenarios, right? I don't know why it is behaving like this. Okay, we'll try to check for all possible scenario. Okay, actually, I have dual booted my computer with Linux because I have to do some SD work, so it is not behaving well since then. Okay, now what will I do? So, see, I will do what I'll try to use recursion here. So, let's have a look what I can do. So, what I will do here is see, first of all, can I say that I'll find the sum, like, let's say I'll find the total sum, right? Let's mark the total sum initially as 0, and I'll find the total sum of the array, right? Yeah, thanks a lot, Shubham. So I starts from 0, I is lesser than n, and then I'll do an I plus plus, and I'll say that okay, total sum plus is equal to array of I, right? Total sum is equal to nothing but the sum of the all the I elements, right? Sum of all the elements of the array, right? Is that clear? Because that is required for me. Then I will do what? Then I'll write a recursion. Okay, I'll start from which particular element? I'll start from the 0th element. Again, I can see people watching are more compared to the likes. So please hit the like button if you haven't. Okay, now going further, see what will I do? I'll start from the 0th index. Correct, guys? I'll start from the 0th index. Correct? Definitely, I'll start from the 0th index. Initially, what is going to be the subset sum S1, right? Initially, I can say that int S1 is going to be what? 0, right? So I'm passing S1 as 0 initially, right? Is that clear? You can write 0 in the chat. You can write 0 in the chat. Initially, I have not taken any element in my subset S1. So that is why the sum S1 is going to be nothing but 0. Is that clear? Is that clear? Now, going further, I need to pass the array as well. Okay, I'll pass the array, and then I'll pass the n value as well, suppose, right? And is there anything else that I want to pass? Yeah, let's say for now, I also want to pass the total sum. Okay, currently I'll be doing in a brute force fashion. Okay, now this is what I'm doing. Now I'll write int recursion here. I'll be at the index I. Okay, and I will have the current sum like S1. Then I'll be passing the array obviously, and after passing the array I'll also pass the n value inside this function recursive, and then I'll also have the total, right? Total sum. Okay, this is what I'm having, guys. Okay, now what will I do going further? So I will simply say that, what will I say? So I'll say that, let's say that obviously there will be a base case in recursion, I'll come to that. But if I take the ith element, right? If I take the ith element, then what will happen? I'll call the recursion for the next element. Okay, I'll call the recursion for the next element. If I'm taking the ith element now, then up till now my subset sum was S1, right? If I am at a particular ith element, right? If I am at a particular element, let's say array 5. Okay, and up till now, suppose my sum is S1. If I take the ith element now, then my subset sum will of the subset first subset S1 will become S1 plus array 5 if I take it. If I don't take it, if I not take it, you can say, then it will remain the same as S1. You can write same in the chat as a acknowledgement. Correct? Is that clear? I hope everyone is clear with this. So what I'm going to do here is I'll have it for I plus 1, and I'll pass S1 plus array 5. If I take this ith element, right? Then this is going to be the scenario. Then I'll pass the array, I'll pass the n value, and I'll also pass the total sum. Okay, these are the things that we are going to pass in. Is this particular portion clear? Right, this is one of the concepts. Now what is the other concept that I don't take it, right? If I not take, so if I not take, then I'll call the recursion, I'll move to the next element, my subset sum will remain the same as S1. You can write a plus 1 chat if you are clear, and then I'll pass the array, I'll pass the n value, and I'll pass the total sum here. Okay, is this part clear to everyone? Right, is this part clear? And in the end, I can say that what will I return? I'll return the minimum of both the scenarios. Now, minimum of taking it or not take, right? Minimum of the take or not take, correct? Okay. So, Hussain, are you clear with it? Rishit is clear with it. Okay. Joel, are you clear with it? Sevak, are you clear with it? And other people are clear with it or not? Right? This is what I will do. Correct? Absolutely. Now I'll return what? I'll obviously be returning the minimum of the take or not take scenario, right, guys? I'll do what? I'll return nothing but the minimum. So when I say that I'll return the minimum, now, so can I say that recursion will always have a base case, right? Recursion will always have the base case. Now, what is the base case? Not take, not clear. Okay, so if you okay, not take is not clear. Okay, why is it not clear? Why are we are not using the, yeah, I will tell you now, Rishit, where we will use it, because I have still not written the base condition, because since this is recursion, so we will do what? We'll also be writing the base condition here. So I've not written it yet. Now not take. So see, if you like, there are many scenarios now. If you are at an ith element, let's say RFI. So if you take it, then the subset sum so far plus the ith element sum, that is the new subset sum. But if you don't take it, then the subset sum S1 remains the same now. So you'll try it for all the possible scenarios. We are not using. Is that clear up till now? Right. Now what is the base condition? What is the base condition? So you can say that what will I do? If you talk about the array that has been given, suppose this kind of array, so suppose this is index 0, index 1, index 2, right? So for like this is I value, right? Again I value. So I value is here n minus 1. When I reaches here, na, when I is equal to n, when I is equal to n, then the array gets exhausted, right? Then the array, yeah, where will we use it? I'll tell you. So if the array gets exhausted now, if the array gets exhausted, then I will check now. In that case, I must have made my subset. Are you getting this point? If I want to make a subset now, so when I is equal to n, then I don't like, I must have made my subset because I've exhausted all the elements. Just go with recursion, leave of faith. Okay, so see, what I'll do here is, if I'll say that again, a lot of people are watching, so you can hit the like button. So I is equal to n. Okay, if I is equal to n, right? So if I have exhausted the whole array and I have built a particular subset S1, please write S1 in the chat. If after certain point of time I have taken some ith index, not taken, and one by one I kept on moving, right? And I is equal to n. Okay, once we reach the end of the array, then our S1 is ready. Yes. Now our S1 is ready, right? Now our S1 is ready. S1 is ready, right? So subset 1 sum is S1. What is the subset 2 sum, right? What is the sum of the subset 2? So it is nothing but total sum. That is when the total sum comes into play, right? So what is the subset 2 sum? It is nothing but total sum minus S1, correct? Now what do you want? You want what? You want the absolute of, you want to do what? You want to return. Now you will try to build all possible S1. Now you can write S1 in the chat as an acknowledgement. You will try to build what? You will try to build all possible S1. You will try to build all possible subsets S1, and correspondingly you can get the all possible subset S2, because S2 is going to be nothing but what? S2 is going to be nothing but total sum minus S2. And you want what? You want the absolute of S1 minus like S2 minus S1, right? You want this particular value, right? So you want all these values and you will take the minimum out of them, right? You will return all the possible values, right? You will do what? You will return all the possible values of absolute of S2 minus S1. You will do this particular thing, and then out of all those scenarios you'll always take the minimum. So in the end you are going to return the least value of S2 minus S1. Now what is S2? S2 is nothing but what? Total sum minus S1. Okay, minus S1. So now minus S1, I can write it as minus 2 times S1, right? So I will be returning what? From this particular function, I can simply return this particular thing, right guys? I can simply return this particular thing, because that is the absolute of S2 minus S1 is nothing but what? Absolute of this particular thing is nothing but total sum minus 2 times S1. Is that clear? That is how I'm calculating the sum. Please give me a +1 guys if you are clear with it. If there's something that you want to ask, you can definitely ask. I saw the same. Okay, yeah, right. So this concept is clear, right? Up till now this particular concept is clear to all of you. Just let me know guys, right? This is what we have done. Okay, a lot of people are giving +1, right? So this is what we have done. Now let me do one thing. I hope that I have not made any mistakes. Let me try and submit this code, compile it and submit it and see what happens. I hope it works on the samples at least. Okay, it says that return recursion. So expected a colon. Where is it expecting a colon? Did I make some mistakes? Okay, yeah, I need to make a colon here. Now let's try and compile it to see how much does it work. Okay, yeah, it's still okay. It works fine, right? It works for the samples, right? You can write works in the chat. Now let's try and submit it and see what will happen here. What will happen here? Okay. Okay, okay. At least we get a tanglet exceeded, right? What are we getting, guys? What are we getting? We are getting a TLE, right? We are getting a TLE. Why are we getting a TLE? We are getting a TLE. You can write TLE in the chat. Everyone can write TLE OP in the chat, right? TLE OP in the chat is what I'm expecting from everybody, right? Why we are getting a TLE? Because when we use recursion, right? When we use recursion, so you can say that, like, see, for one element now, I have a scenario like either take it, not take, right? So for like one element, I have two choices, right? So there are n elements. For one element I have two choices, for another element, for the next element I have two choices, for the next element I have two choices, for the next element I have two choices, right? Up till like this. So you can say that I have 2 to the power n complexity here, right? Because for every element I have 2 to the power like I have two choices. So for one element I have two choices, for the next element I have two choices. So overall complexity, you can say, for generating all the possible subsets S1 is going to be nothing but 2 to the power n, right? It is going to be exponential in nature, right? You can write expo in the chat, correct? It is going to be exponential in nature. And since it is exponential in nature, right? So this is what is happening when you see recursion now. So there are a lot of overlapping, okay, overlapping sub problems, okay. That is when what you can do is you can memoize it, right? You can use the concept of memoization. You can write memo in the chat. You can use the concept of memoization, or you can say bottom like top down dp, sorry, you can say it as top down dp, right? Top down dp. Okay, so if you will observe now, if you will observe, like I'll tell you one thing very basic that I have been telling very from a very long time. Okay, can I say that? Can I say that, guys? Can I say that I'm giving you a reference? Can I say that nth Fibonacci number is what? Sum of the n minus 1th Fibonacci number and the n minus 2th Fibonacci number. Correct. This is one concept. So basically, I am saying that if I want to find the 6th Fibonacci number, so I'll call for the what? I'll call for the 5th Fibonacci number, and I'll call for the 4th Fibonacci number. For the 5th, I'll call for the 3rd, 4th, and the 3rd. Right. For the 4th, I'll call for the 3rd and the 2nd Fibonacci number. Right. For the this thing, for the 4th Fibonacci number, I'll call for the 3rd and the 2nd. Right. For the 3rd, I'll call for the 2nd and the 1st. Right. For the 3rd, I'll call for the 2nd and the 1st again, let's say. And this is the base case. Suppose f of 1 is base case and f of 2 is the base case here. Right. So here I'll call for f of 1 and f of 2. Right. Can you see that I have done a lot of what I have done in this particular case? This is the Fibonacci example. Then I'll give you another example as well, another perspective. Okay. So you will see here. Can I say that f of 4 is already calculated here? Yes. So f of 4 is already calculated here. So if f of 4 is already calculated here, suppose, right? So will you calculate something that is already calculated again? No. No. If you calculate something, na, so you'll store it. You'll store it. Right, that is the concept of memoization, so that you don't calculate it again, na? Because you don't want to calculate things again and again. Na? That will make your program repetitive in nature. Are you getting this part, guys? Everyone is getting this particular concept? You can write a +1 and hit the like button if you still haven't, right? Are you getting this particular concept that if f of 4 is not calculated, if it is -1, then you'll calculate it. Otherwise, if it is already calculated, then you will not calculate it. You will simply return from here, because you will not call so much down dp. Like you will not call the recursion so much down, right, guys? Understanding this? Okay, a lot of you are giving a +1. Others can also give a +1, Shubham and other people also. All right, great. Now let's talk about one more thing, right? Let's talk about one more thing. Suppose that you have I comma j kind of concept. Okay, so how many variables are changing here, right? How many variables are changing? So see, if you will see here now, can I say that if you will see, array is the same, right? Array is remaining the same. How many parameters are changing? Array is the same, right? N is also the same, because size of the array is the same. Total sum is also the same. What are the two parameters that are changing here? The two parameters changing here is nothing but index I, and S1 is also changing, right? The subset sum is continuously evolving, right? You can see S1 plus array I, or maybe it remains the same also. So I is changing, and subset sum can also change, S1, right? You can write yes in the chat. Okay, +1 in the chat if you're clear with this, that these two things are changing. I and S1 are changing. Now I'll tell you one thing more. Okay, suppose I write a function like this. Okay, suppose that I am currently at index I and j, and suppose things are varying. Okay, suppose that things are varying, so you'll understand dp much more clearly after this example. So if you have I now, okay, if you have I, so one thing that you could do is, let's say I'm building a function. Let's say you're calling for I+1. Okay, one time you increment your I and then your j. Okay, then you can say that maybe I remains the same, j changes. Okay, is that clear? You can write 2 in the chat. If you can see that both, there are two parameters that are changing. Suppose that there must have been other parameters that are not changing. Please write 2 in the chat. Suppose that one time I'm incrementing the first parameter, keeping the second as the same. One time I'm keeping the first as the same and incrementing the second one. Is that clear? +1 in the chat, and then I'll explain this one also. You can write 2 in the chat or +1 in the chat. Okay, so one time I'm going to increment the first and keep the second as the same. One time I'm going to keep the first as the same and increment the second. Okay, now understand this thing, what will happen. Now if you will observe that, because you should not directly apply dp without visualizing it. So suppose that you have 0, 0 here. Okay. Now one time you increment your this guy and keep this as the same. Now another time you keep this as the same and increment the second part. Now what you do is here you keep this as the same. Keep increment the first parameter y1, keep the second as the same. Increment keep the first as the same and increment the second one. Okay. Now keep increment the first one, keep the second as the same, and here what you do is you keep the first one as the same. Basically I'm saying that I comma j is there, so one time you do I plus 1 comma j and another time you do I comma j plus 1. Okay. Now here what you do is you increment your j, you here you increment your I, so let's say you do 3 comma 0. Now this will be what, this is going to be 2 comma 1, this is going to be what, I think it's going to be 2 comma 1, right? And this is going to be what, 1 comma 2, right? This is going to be what, 2 comma 1, and this is going to be 1 comma 2. Let's say this is going to be what, 1 comma 2, and this is going to be 2 comma 1. Okay, let me just do this thing. All right. Now observe one thing, guys, with me. Okay, observe, right? Observe one thing. Can I say that this particular state, look at some states, right? Can I say that 2 comma 1 is calculated here, right? Here. This is a very basic example to understand why a lot of sub problems might be already calculated. You can see 2 comma 1 is here, right? 2 comma 1 is here. Can I say that they are all, if you have calculated it once now, so then you will not want to calculate it again, not want to calculate it again. No, you will not want to calculate it again. If you have calculated, see, if you have calculated 1 comma 1 state like already, right? If you have calculated this particular state already, will you calculate this state again? No, you will not. You can write no in the chat. You will not. Obviously, you will not. Correct. So that is when you will use the concept of dp, or you can say 2d dp, because I is changing and the sum is changing. So this particular condition is clear. I have used a basic example for clearing this particular fact why we need to use dp. You can write a clear op in the chat, or clear or +1 in the chat, whatever you feel like. Because this is a good example, to be honest, a very basic example and a good one also. Okay, so let me see the chat. Rishit is saying +1. What about others? Others are clear. Overlapping sub problems. If a particular state is already calculated, you will not calculate. Two parameters are changing here. Basic example, like I, basically I've said na, I to I plus 1 comma j, and you can say I comma j plus 1. All right, great, guys. Okay, now similarly here you will do what, you will use dp, right? So what I can do here is, if you will observe here, so I can use the dp concept. Please write dp op in the chat is what I'm expecting. Okay, so what will I do here? I'll declare a 2d dp, let's say, of vector of let's say vector int. Okay, and let's name it as dp, and let's name the size as n, and then I'll do vector of int. Okay, I'm going to store this sum. So right, so I'll declare it like this, and then I'll have the sum comma n minus 1, and this is how I'm going to declare it, and I'll pass the dp here. All right, and here also I'll pass the dp array. Here also I'll pass the dp array. Okay, now what I will do here is, if it happens that dp of I sum, okay, if it is not equal to -1, okay, if it is not equal to -1, okay, so this means that it is already calculated. You can say already calculated. If it is already calculated, then you will not calculate it again. You can write not in the chat. I'll not calculate it again if it is already calculated. In that case, I'll directly return what, dp of I sum. Okay, this is something that I'm directly going to return, guys. Okay, if it is already calculated, then I'll directly return it. Otherwise, if it is not calculated, then what will I do? I'll simply say that before returning it, I'll first of all store it. So I'll say that dp of I sum is equal to this particular thing. So I'll store this particular thing. Why we need to pass dp as well? Okay, yeah, I need to pass dp here as well. Yeah, right. So I'll say that vector of okay, vector int ampersand dp. Obviously, I need to pass it, right? And I will pass it like this, so that any changes I make to the dp will be reflected. Okay, you can declare it as global as well if you want. So what I will do here is, I'll simply say that if it is calculated already, then I'll directly return the calculated value for this particular state I comma sum. Otherwise, what I will do is I'll store it. Please write store in the chat. No? I'll store it here. So I'll store this particular state, so that next time I do not calculate it again. Now, those who don't remember the past are condemned to repeat it. So you don't want to repeat it, so you will store it, right? And then after storing, you will return. Like you can write SR in the chat as an acknowledgement that first of all you will store it and then return it. Okay, then you will return this particular state after doing this particular thing, right? Let me try and compile it. Maybe I might have made some compilation mistakes, syntax mistakes. Let's see. what happens? Okay. Okay. Yeah. So I should say S1, not right, not sum, but S1. Sorry. I should say it as S1. Okay. I went with the flow. I should say this thing as S1. Sorry. Instead of sum, I was using S1. Now let's try and compile it again to see how it goes. Hopefully this should work. Okay. Yeah. So I should use the total sum, let's say here. Because the size is n and the total sum is sum. Total sum is total given also, right? Okay, so yeah, it works on the samples. Let's try and submit this particular code as well. Can we submit it? You can write submit in the chat. Let's see how it goes. I hope it passes all the test cases, right? Yeah, it passes all the test cases, right? You can see that all the test cases have passed here, right? All the 1020 test cases have passed. So this is how we solve this particular problem. Is that clear to everyone? Is that clear to everyone? Too fast now. Okay, so which part you did not understand, Hussein? Okay, I'll explain it again. See, what we have done is we need to store the states that are already calculated. So that is why I have declared a 2D DP. Okay, you can say this thing that I have declared a DP of this type. I have declared a DP of the n elements, right, and the total sum, right. So that is going to be my DP dimension. Okay, so I've declared a 2D DP like that, and I have passed it in the function as well. Is that clear to everyone? Guys, are you clear with this thing? Just quickly let me know. I'm still waiting for your responses. I don't know if my internet is working low or what. Okay, so see what I've done is no sir, code working too fast now. No, sir, code working too fast. Okay, code is working fast. Okay, I thought I am I am too fast. Okay, great. You can write clear in the chat now as an acknowledgement if you are still here. Right, so what I'll do is I'll declare a 2D DP of dimension n cross the total sum because these two things are varying. So in the worst case, you can say, what will I do? I'll declare a DP which will store all the n indexes and you can say the total sum, right? Because in the worst case, the indexes can go till n and this will be total sum, right? So that is what I'll do, and I'll pass this DP here as well, and I'll pass it with ampersand, that is passed by reference in C++, and I think in Java it will be directly passed by reference, right? Then again the same thing is there. If I is equal to n, then the first sum is nothing but what it is, nothing but total sum minus s1, and minus s1 again I'm doing. So this total sum minus 2 times s1 is what I'm getting, right? So that this is every time I'm returning all the possible, you can write all in the chat now. I'm returning all possible absolute sum, like I'm returning all the possible absolute difference. So you can write all in the chat as an acknowledgement. I'm returning all possible absolute differences, and then simply what we are doing is every time we are taking the minimum out of all the cases, right? And once we have taken out all the minimum, right, so basically you can see that there will be a lot of overlapping sub problems. You can write clear in the chat now. I hope that this kind of diagram is clear. You should never forget this kind of concept in your life. This concept that I have just told you overall, like when let's say I and j are varying, like I plus 1 comma j and I comma j plus 1. So this is where you can see that overlapping sub problems are there. Similarly in this kind of problem as well, two variables are varying, so there will be overlapping sub problems. Obviously when you will draw it, it will feel a little bit difficult, right, to draw sometimes. So if it is already calculated, then I'll not calculate it again. Will you calculate it again? No, obviously not. So you'll directly return it. Otherwise you will like if you will take both the scenarios of taking the ith element into the sum, that will be s1 plus rfi. If you don't take it, then that will be s1 directly passed. And then what I have done is basically if it was not stored, then I'll store it so that I don't have to calculate it again, and then I'll return it in the end. Is that clear to everyone? Is the overall question clear to everybody? Yes or no? So some people are saying that can we solve it using 1D? Maybe you can try those approaches, but as of now I am running out of time, so I cannot solve more than like I have explained this from scratch very easily. So you can write easy OP in the chat. Nah? This was easy problem, right? Easy, right? The GFG problem setter was a bit like GFG problem setter thought that it was a hard problem, but it was an easy problem for us overall, correct? So you should solve the POD. Like you can see This problem has been asked in Amazon, Samsung. Some good companies have asked this particular problem. And also, one more thing you can do, you can read the interview experiences related to this. That can also help you by reading the Samsung experience and all those stuff. You can get the idea like how they are asking this thing, right? You can click on this, and when you will click it, so you can see that this question was asked somewhere here and there. So you can read other questions as well. That is what I'm recommending to all of you as well. Okay, so is everyone clear with this? You can just give me a +1 before we end this particular stream. And now the problem of the day for today is going to be jumping game. So you want me to give you the code for this problem as well? I'll give you the code as well inside the chat. Just a second. I'll try to copy this particular code. Okay, so let me generate the URL for this code. Okay, just a second, and let's do this. So I'm just running it on the URL. Is everyone clear with this overall? Okay, now let's try and copy it, and I'll paste it in the chat. Okay, so this was the problem of the day for yesterday. Make sure to go through this code and try to submit your approach by on your own as well. So is everyone clear with the problem overall? Like you can write a +1 again for the one last time. I'm still here for 30 seconds, and you can open this link obviously. Like I've given the question in the the solution link in the chat, so you can try to go through it as well. So this was the problem of the day for today. I hope that you all enjoyed it, right? You learned something new from it. You can give me a +1. Okay, obviously I hope that you did. Hussein is saying yes. Okay, great. So all right, so again adding my screen to the screen, so you can solve the problem jumping numbers. I think Siddharth will be taking this problem tomorrow. It has been asked in Amazon, so I think this problem is easy one, so try it out. It's a medium level written, but I think it's easy one, and it's based on the concept of mathematics. So you can try this problem out, and Siddharth will be there with solution. So you can write GN in the chat, and then we can end the session as well. Okay, and make sure to solve the problems, everyone, guys. Okay, great. So thanks a lot everyone for joining for today, and it's very late night, so great that you are solving these problems. Now make sure to submit the problem of the day for today as well. And bye everyone. Good morning. Okay, bye. Thanks a lot Hussein, and thanks a lot Rishit. Thanks a lot everyone for joining. Make sure to hit the like button if you haven't, and that is it for today. Bye, good night, and take care.